When in thermodynamics we're talking about spontaneity and we use the Gibbs free energy to decide if a process is spontaneous, that is, if a process is going to move forward, one always have to keep in mind two main things. First of all, that even in the case where the process is not, when your reaction is not spontaneous, there's always going to be some products. This just says that there's going to be more reactants than products. And that's a specific definition that we need to keep in mind. We will not go farther into it, but at least even if the process is not spontaneous in a chemical reaction, you will still have some products, not as many. And as you can see, we will be able in the next videos to relate this to the equilibrium constant, but there's always some products. As little as it may be, there's some of them. The other aspect, and the one that we are going to talk about now, is that this just talks about how stable products and reactants are, the direction, but does not talk about the speed at which that process or that change takes place. The speed is related to kinetics. In other words, you may have a very spontaneous reaction, but you may not see any products because the barrier, the energetic barrier separating the reactant and products is too large. In this case, you can say that some reactants or some products can be trapped, can be kinetically trapped by a large barrier. So in this case, even though reactants are more stable, and in this case you should see a delta G being positive, you may see some products, not only because there is always some products according to the equilibrium constant, even it's smaller than 1. You will see also products because sometimes it just takes a long time for equilibrium to be reached, so you will see products being trapped. This is why we introduce the concept of a substance being kinetically or thermodynamically stable. In a situation, in this case, you may see a lot of products in here, not because they are thermodynamically stable, because clearly reactants are more stable, so eventually products should start becoming reactants, but if you see a lot of products, it may be because those products are trapped in this kinetic well, and therefore they're just stabilized not by thermodynamics but by kinetics. And a good example of that is when we study the two forms, the most popular two forms of carbon. There are more, but these two both exist. You have seen in your pencil, that's carbon graphite, and so you may have seen or may even have one diamond, that's also carbon diamond. These two, so you can think of a reaction going from carbon graphite to carbon diamond, okay, and this reaction may be positive, may be negative, and yet both of them exist. Let's see which one is trapped in a kinetic barrier, which one is actually thermodynamic stable. Let's decide which is kinetically stable, which one is thermodynamically stable. So for this reaction, and notice we could have done the opposite reaction, so we're gonna include in this case, so diamond is gonna be my products, so let's say delta H is enthalpy of products, that is of diamond, minus change in enthalpy of reactants, that is of graphite, and I go here. So diamond is 1.9 minus 0, this is 1.9 kilojoules per mole. In other words, it's positive. The delta S is the S of products, diamond, minus the S of reactants, which is graphite. That is 238 minus 5.74. Again, this is negative. In other words, notice that being enthalpy always positive and being entropy always negative, this will always be negative. So if we were to plot the delta G in terms of carbon graphite and carbon diamond is kinetically stable. So let's make it even more exaggerated so that the barrier separating the two is large enough so that carbon diamond is kinetically stable. Otherwise, if only thermodynamics were to decide the outcome, you would mostly see carbon graphite, and your ring, if you have a ring with a diamond, would start getting black because it becomes graphite. And yet that does not happen in a long time. It means that carbon diamond is kinetically stable, and even though thermodynamically you should only see or only mostly see carbon graphite. We can apply this to many instances in our daily lives. There are things that just exist, and one example would be just you. You are made out of carbon and you're surrounded by oxygen. We are only stabilized by the energy barrier between us and just CO2 and water. So think of, if you ever think of yourself of too much, think of it that nature actually prefers you if you are in form of CO2 and water. You are just kinetically stable.